This is a picture of Narragansett Beach. Somewhere close to there, a mysterious blast happened. Here's an article. Rhode Island Beach fully reopens after mysterious blast. A Rhode Island beach where a mysterious blast sent a woman flying has fully reopened even as authorities continue searching for the cause. A section of Narragansett's salty Brine beach was cordoned off after a Connecticut woman was thrown into a nearby jetty following a loud boom on July 11th. Department of Environmental Management spokeswoman Gail Mastrati says that the roping in the area was removed Tuesday morning. She says the scientific team finished their soil samples late Monday. Mastrati says the Department of Environmental Management likely will learn the results of the testing next week. Governor Gina Raimondo says state officials are working to figure out what happened. Fortunately, as of July 23rd, 2 weeks after the blast, a local professor, Gaby, has figured out the cause of the blast. Stay tuned and he will reveal his research.
See, it's low tide at about where this woman was sitting. Her event happened at about 11 o'clock. Notice these dark lines in the sand. It shows that there's a lot of magnetite in the sand, as well as whatever else sand is made of, and that is quartz and feldspar. So I'm not sure if this is a particularly magnetic feature or not, but you can see the dark bands in the sand that result of the waves sloshing back and forth. I'd like to inspect other areas of the beach, but again, what kind of exacting photographer do you think I am if I don't explore every aspect of the beach in front of us? It's fun to see the kids playing on the rocks. It's fun to see the older people hanging out on the rocks and looking over the kids. That's important, that they don't get swept out to sea by any of these strange aberrations. I see one coming in right now, and coming and going all the time. This beautiful rock in front of us has little like white eyes to it. Organite, it would be called. The other pinkish rock most likely came from the westerly granite quarry. There's a lot of pinkish or feldspathic looking rock, and it comes from the granite quarry that we have around here. Very special granite here in the southeastern part of New England. More of this beautiful granite. Pardon me. More of this beautiful pink granite, and of course you can see how they used to quarry this stuff and then move it. You drilled holes in it up and down and stuck plug and feathers in and tapped it open until the rock would split apart. One of the fascinating aspects of the granite is that there are some parts of it that have cooled very slowly and have separated crystals, as we can see. The gray area is the last to cool, and that would be the quartz. The earliest crystals to form would be the feldspar, and you can see the salmon-colored feldspar. That's called potash. And the white-colored feldspar, you can see they do have crystalline structures to them. That's called algite. And finally, the quartz crystallizes last, which is then there's a very slight sprinkling of mica throughout this particular granite. It's called a pegmatite, but it also is proof to us that the last material to solidify in any one of these hot magmas is quartz. And sometimes it shoots to the surface, and when it shoots to the surface, it brings with it some other materials that have been dissolved in that hot liquid quartz, like gold and silver and copper. Boy, thank you. Okay, we are here at Salty Brine State Park in Rhode Island, right where the Block Island Ferry leaves. And we came here to recapture something that happened almost 10 days ago, which is where a woman, right where these kids are playing here at the edge of the beach, was supposedly thrown 10 feet into the air and against the rocks. About a 60-year-old woman, and they came upon her unconscious lying. I get a shot of Rhode Island's finest, and that's who you are, Adam, and because I wasn't able to do that, so I do want to put you on the front page of Time magazine, because how come they put this thing on CNN? They said that, right? Did you hear about it?
Yeah, on CNN.
Yeah.
Yeah, I don't know why.
It's crazy. It's going to be in one of these UFO files.
Yeah.
You know,
yeah, definitely.
Phenomena unknown. Again, thanks. Have a nice day. And I will bring this thing up to the height where you can see it. So what I'm going to do is to touch these two probes together and see if there is really electricity flowing through this. Hopefully you can see it or hear it. Ah! Yes. See? It's trying to weld together. So there is electricity flowing through there. And what I'd like to prove is, if I submerge this in the water attached to the electricity, it will cause the water molecule, which is 2 hydrogen atoms and 1 oxygen atom, it will cause it to rip apart. And the hydrogen atom of the water molecule will be racing to pick up an electron where the cathode is, and that would be the ground. The oxygen, on the other hand, will have too many electrons, so it will race over to the positive end of the terminal. Well, we're going to try that, but of course you say, how am I going to prove that we're going to be getting gases bubbling up through here? We will place this platform in the water, in the salt water, and of course it may try to float away unless we have some nearby rocks to keep it steady, and we'll try to find those. Just a couple of rocks to keep it underwater. Now, I do want the probes under the water, and I do want the electricity attached to that. But we have a dilemma here, in that our power supply is all the way back on shore. And let's see how long our power supply can stretch out to reach these things. And I imagine it has to be a little bit waterproof. So one of these will go to here. Okay, let's try to make it stick. One of these will go to here. Okay, and the other one will go to here. And apparently it's sticking. Well, I'm not going to turn anything on yet, but what we're interested in is how to collect, how do we prove that the oxygen and hydrogen are being stripped from one another? Well, I'll take a credit card. That's all it's useful for. And I'll fill up these 2 bottles of water up to the top, and make sure that they are filled up to the top, and try to place them on top of each of these, which I was not too successful doing just now. So we'll do that again. I'll tell you what, I will tilt these over with the tide, Come on, and then do it. Yep. Okay, we got this one on. And the other one, we'll do the same thing for. Tilt this one over. And now we have two upside down. Oops. Two upside down containers of water. So what I have got to do is turn on the electricity and see what happens. Once the electricity is on, like right now, what should happen, already notice, can you see that there are bubbles coming up from the negative cathode, and they are furiously coming up. There should be bubbles coming up from the positive anode. But what's happening is the water in here is being displaced. Now what we said was that the hydrogen arm of the water molecule is kind of positive, so it will be pulled off by anything that wants to contribute electrons to it and become a gas. So what we're looking at, let me see if we can see it. Come on, let's see if we can zoom in on it. If nothing's in the way. Good. I can't believe this is working so perfectly and I haven't tried it before. What we're looking at is the left side of the upside down cup filling up with gas, and it's actually filling up with hydrogen gas. We are right now ripping a water molecule apart in the ocean, and you can see that. I'd like to get it closer. Only way I can is if I dismember everything and pull it closer, but I'm doing so well now I don't want to upset it. But you can see on that left upside down cup that the water level is going down, it's going down, it's going down, and that is because it's filling up below with hydrogen gas. So just that little battery charger, the black end of the battery charger is the cathode, which wants to contribute electrons, and the electrons are immediately grabbed up by the positive end of the water molecule, which is a hydrogen atom. And so as soon as the hydrogen atom, which is positively charged, picks up an electron, it becomes a gas. And so we have hydrogen gas forming right there in the left upside down bottle. What should be forming in the right upside down bottle, although it's not as evident because there's a difference in atomic weights between hydrogen and oxygen, what should be forming is that once the hydrogens are stripped away from the oxygen, the water molecule, that leaves oxygen, and the oxygen is therefore negatively charged. So the oxygen is going to race over to that little anode that's under there, and it will give off its extra electrons and become oxygen gas. So this should be filling up very slowly with oxygen gas, but this side is filling up very fast with hydrogen gas. So our point in this issue, I gotta get my face in, right? Our point in this issue is whenever we have wires underneath the sand in salt water, whenever there is any kind of current going through those wires, and if the wires are broken, there is going to what's going to happen at the break of the wire is something called electrolysis. Electrolysis is where we take a water molecule and split it into hydrogen and oxygen. So that's going on right now, even with just a little DC generator, a DC jump charger. Now, I guess I should shut it off and get a little close-up view because I'm so happy that this has happened. Hope I didn't run out of batteries. Let's see. Let's try to get closer if we can. Okay, and and go down to there, and I think we can, right there, everything's kind of like mixed up, okay, I think we can right there, yep, there, I think we can get a closer look at the bubbling up of the hydrogen bubbles in the left-hand container, and we can't quite see the oxygen forming up in the right-hand side. Well, this of course is the solution to all of our energy problems on Earth, is we have an infinite supply of hydrogen and oxygen, and there it is in front of us. It is the ocean. And if we had excess electricity flowing around, like from downtimes from nuclear power plants or whatever it was, we can be electrolyzing water and producing vast stores of hydrogen, which we can run hydrogen cars on, or we can burn, use it as methane, and of course it would produce oxygen too, which we have in a bounty of use for. So what this wants to demonstrate here, what I'm trying to demonstrate, is at that Rhode Island beach where there was an explosion, underneath the rock jetties there were many lines of Coast Guard big wire cables that went all the way out to the end to light beacons. They pulled one out, but they didn't pull all of them out. And normal variations in the Earth's magnetic field produces something called telluric currents, or there's always currents going in and out of those cables that are right down there in Galilee. And eventually, with the salt water attacking the cables, there will be rupture and corrosion, and the lines will split, and we will witness exactly what's happening in front of us. There will be hydrogen bubbles that will start accumulating down below. If there's a lot of pressure on top of the hydrogen bubbles, well, they're not going to release for a while. Just before the lady was blasted into the air, at that time, July 11th, people noticed bubbles in the water. And apparently the bubbles were out in the water offshore just a little bit, and then they came closer, and all of a sudden she was in the air. So the spark that happened across that open gap of conduit is what ignited the hydrogen and blew it up. Now you say there should not have been a real current. Well, of course, there's no definite current attached to, you know, any kind of light or anything, but there's always induced currents. Currents are always induced just by the geomagnetic field. Now I've got to watch a second here, because I see I do see waves coming in, and these waves may try to upset my balance. We'll find out. I just don't want them to knock everything over. As long as the waves pass, we're all set. So again, this is electrolysis, and this is the reason for that happenstance. The bubbling up of the hydrogen from the Earth, and all of a sudden it igniting and blasting open, is called an earth burp. Somebody call that, not me. I heard it called that an earth burp. And I see we're still recording, so we are on fantastic control. Now, I noticed that the level of the water, which is all the way up to the top, has gone down already 3/4 of an inch. I think that was in about 10 minutes. So if we waited another 10 hours, or whatever, not that much, we would see that upside down container, that cylinder, become completely empty of water. The water is being pushed out because the hydrogen is pressurizing up at the surface, and then we would have a whole container of hydrogen. Then what I would do, which I would love to demonstrate, but usually, you know, in a chemistry class you demonstrate these things on a smaller scale. And then what I would do is I would take that glass container on the left hand side, and I would quickly turn it upside down, and then put a light to the gases that have accumulated there, and we would hear a pop. There would be a big bang, there would be a pop. and that would be proof positive that hydrogen collected there. Now, if we did the same thing to the other container, if we put the flame there, what would happen is the flame would simply be enhanced because there would be more oxygen. It would enhance the flame, but there would not be an explosion. So, I'm very happy to have at least demonstrated this. I don't think I can produce the pop for you guys right now, but I can, since everything's working so well, I can try to take our camera and view around the neighborhood and see how everybody is doing. Let's take a look, because we're doing awful well. We've got our electrolysis going on, and we have boats going by. We have a jetty right here. We have rockweed in front of us, which is very healthy. And guess where we are? We are down in, right now we are down in Stonington Harbor. Not quite Stonington Harbor, we are down at Lighthouse Point. But we are on the west side of Lighthouse Point, because the wind was on the other side and too many people were on the other side. So that's why we took this little comfortable location right here. One of the recent problems we discovered with this side of Stonington Harbor, including all of the Pawcatuck River and Little Narragansett Bay, is that instead of the beautiful long eelgrass that it used to grow, it's been replaced by a real evil called Claudifera. In the paper they should have used the common name that I used to use when I taught oceanography, and that was maidenhair. So it is a very filamentous algae that is very thin, and so when it dies and collects to the bottom of the nearby shoreline, it just mats and it starts rotting and stinking. So that body of water that we see in front of us is very unhealthy. And of course we're looking at Watch Hill Lighthouse straight ahead of us. Boat just went in front of it. Nappertree Point, a buoy. The other side of Stonington Light is much healthier, though. The Stonington Point is much healthier, though. So, again, I can see that we're doing really well, and our tubes are filling up. Look at that. The left tube is already 1.5 inches down. Oh my God! You may call me to my task by having me wait around for another half hour so it totally fills up, and then I'll put the spark to the end of that, and we'll have kind of a boom, kind of the same boom that they had in the Challenger disaster, hydrogen explosion in 1986, or in 1937, the Hindenburg blowing up. We don't want those bigger booms because, you know, the neighbors might get really upset. At any rate, if I was able to do this without having practiced it, you can see that it looks simple enough, and I am here on the again, I'm not sure if I have my timing for the high and low tide correct here, but I have been lucky that I've taken this battery charger, and it's been continuously working. It's already got about 2.5 inches of hydrogen gas on the left hand side. It is pushing the salt water down. Bubbles are still coming up. The water is being displaced. We're collecting hydrogen. If there were a balloon on top of that, the balloon would be filling up. So just think of that for you future science project people. If you have a little smaller area, and if you had a little nipple on the top with the balloon, you could fill up a balloon with hydrogen. And what's fun about that is you can pop the balloon, and the explosion of the hydrogen is not nearly as fierce as the explosion of methane or propane. So all of that is ruled out. We're having a good time here. Thank you for letting me be able to demonstrate this just cold off the cuff. I think what I'll do is I'll I'll put the camera down and see if I can collect that hydrogen somehow. And I don't know. I'm going to see what I can do. Okay, here's what I'm going to try to do. I'm going to try to move this whole unit out into the water. Move it out into the water. And I'm going to try to turn this turn the hydrogen one upside down and put this card on top of it to hold in any gas that's going to try to escape. But I see I gotta go into deep water in order to pull it off of that pin. So I'm going to try to do this. I don't want gas to escape. Here we go. Okay. Okay. All right. I think that's mostly hydrogen in there. Can you see it? I'm going to try to let some of it go and try to ignite it. You only live once. I have no assistance. People don't want to play with me when it comes around to hydrogen and explosives. I don't want the hydrogen gas to escape because any little leak there, it will escape. So let me try to do some lighting and move the top off. Come on, Stan. I got to be able to do it. Ah! Oh. Ah! It worked. My experiment worked.
What's your experiment?
I just collected hydrogen gas with electrolysis, and I just put a match to it, and there was a big bang. Shook me up.
Are you using DC voltage?
Yes. Unbelievable. So this much hydrogen collected in there, and then I slid this off slowly and put the match to it, and the thing shook me up. Unbelievable. Did you hear the pop at all?
I did.
It wasn't as loud as the Hindenburg.
Well, that's thankfully.
I didn't think it'd be that loud. Yeah. And if you have any abrasion in the cable, the salt water is going to eat at it, and there's going to be exactly what happened here was electrolysis, separating of hydrogen, separating water into hydrogen and oxygen. Yep. And so what was bubbling up just before she was blown into the air was they saw bubbles in the water coming towards her, and then boom.
Wow.
I don't want to be famous or anything, but I got because you are a witness. I do have to catch you on tape and maybe everybody else. Here, let me see. Okay. So you are a witness to the explosion. What's your name?
Edward Connell.
Edward Connell. We can believe you, Edward, because you play beautiful mandolin. Is that what that is? No?
That was funny. I heard the little pop.
No? Oh, come on. A big pop.
Not as big as the pop that was underneath that woman.
To throw her 10 feet into the air. I mean, the exaggerations keep going. Now they say it was 20 feet in, you know. But I came down just trying it as an experiment, and
Yep.
this one here, this one here,
Yep, that's Ruby.
Ruby, did you hear the pop?
What?
Did you
Ruby.
did you hear the pop that was made? No.
No.
Okay, not gonna do it again, Ruby.
Okay, it's fine.
It's fine.
Yes, I will.
Can't believe how happy I am that this thing worked, and I think I got it on camera.